Hey guys, welcome to Math for Kids by a Kid. Today we're going to talk about multiplying and dividing radical expressions. This is a rule when multiplying radicals. If they have the same root, then all you have to do is multiply the radicands. So this is the formula with variables, but I'll give you a real example. Let's say you have the cube root of 8 times the cube root of 4. They both have a root of 3, so you just have to multiply the radicands 8 and 4, which is 32. So this is the same as the cube root of 32. Let's keep that in mind, as well as adding and subtracting radical expressions from the other video to solve this. 6 times the square root of 7 plus 7 times the square root of 6 times the square root of 7 minus the square root of 6. So we're asked to expand and simplify these two expressions. So we're going to use the distributive property. We're going to multiply 6 times the square root of 7 by this expression. So it'll look like this. And we're going to do the same thing with 7 times the square root of 6. So add 7 times the square root of 6 times the square root of 7 minus the square root of 6. And from here, 6 times the square root of 7 gets multiplied by the square root of 7 and the square root of 6. So that looks like this. And we have a minus sign here because there's a minus sign here. So it's subtracting. And we're going to do the same thing with 7 times the square root of 6, multiplying the square root of 7 and the square root of 6. So add. And again, we're going to put a minus here. And you get this. From here, we'll multiply these two radicands, these two radicands, these two radicands, and these two radicands with the coefficients in front. So you get 6 times the square root of 49 minus 6 times the square root of 42 plus 7 times the square root of 42 minus 7 times the square root of 36. And 49 is a perfect square, so this just simplifies to 6 times 7. And these two are like terms because they've got the same root and the same radicand, so we just add the coefficients. So we get plus the square root of 42 because negative 6 plus 7 is 1, and minus 7 times the square root of 6, because the square root of 36 is 6. It's a perfect square. So from here we get 42 plus the square root of 42 minus 42, and these are a zero pair, and so we're left with the square root of 42 as our final answer. Now we're going to look at this example. 3 times the square root of a minus 7 is multiplied by 3 times the square root of a plus 7. So these are a difference of squares. The only thing that's different about them is that one expression has a minus sign and the other expression has a plus sign. So it's a difference of squares. So this really expands to 3 times the square root of a squared minus 7 squared. There's no middle term because they cancel out. And so from here, this is 3 to the power of 2 is 9, and the square root of a to the power of 2 just gets rid of the radical sign, so you just get a. And 7 squared is 49, and you have a minus sign here. So 9a minus 49 is the final answer. Let's look at this example. So we're still going to use the distributive property to solve this. So this becomes 6 times the square root of x times 5 times the square root of x plus 8. And minus, because there's a minus sign here, so we're subtracting 3 times the square root of 5, like this. And from here, we're going to multiply this term by these two, and negative 3 by these two terms to get And for these two, we're still going to multiply the radicands, but we're also going to multiply the coefficients. So this becomes 30 times the square root of x squared. And this is just x, because like I said before, the radical sign just disappears. So I'm just going to write 30x here, and plus 48 times the square root of x. So we just have a number multiplying a radical. We just multiply to the coefficient. And same thing here. So minus 15 times the square root of x, and then minus 24. And from here we get 30x plus 33 times the square root of x, because 48 minus 15 is 33, and then minus 24. And then this is our final answer. Now let's look at dividing. So let's say we're asked to simplify this. First, we need to rationalize the denominator. That basically means just getting rid of the radical sign in the denominator so we get a rational number instead. So we're going to multiply both the numerator and denominator by the square root of 6. So we get and then from here it's 3 times the square root of 36 minus 5 times the square root of 6 over the square root of 36. And this just simplifies to 3 times 6 minus 5 times the square root of 6 over 6. And then this is what we get in the end. Now let's look at this example. So before rationalizing a denominator, we also need to check if the radical can be simplified first. So in other words, can it be written as a mixed radical? So if we look at the number 12, that's 4 times 3, but then 4 is 2 times 2. So this can be simplified to the square root of 4 times 3, which is 2 times the square root of 3. So we can rewrite this as 9 times the square root of 2 minus 3 times the square root of 5 over 2 times the square root of 3. And we're not going to multiply both the top and bottom by 2 times the square root of 3. We're just going to multiply the top and bottom by the square root of 3 because that's the irrational part. And so we get 9 times the square root of 2 times the square root of 3 minus 3 times the square root of 5 times the square root of 3 over 2 times the square root of 3 times the square root of 3. Then from here we get 9 times the square root of 6 minus 3 times the square root of 15 over 6, because this is really 2 times the square root of 9, which is 2 times 3, which equals 6. And from here, we can simplify because all these three numbers have 3 in common. So we can just divide each of them by 3 to get 3 times the square root of 6 minus the square root of 15 over 2. Now let's look at this. So the difference here is that the denominator is a binomial, so there's 2 terms in the binomial. We have the square root of 7 plus the square root of 3. So if we want to rationalize a denominator with a binomial, then we use a difference of squares to rationalize. So we take the conjugate of this term, which is the square root of 7 minus the square root of 3, and multiply this by the top and bottom. So that's and so we get the square root of 49 minus the square root of 9, which is 7 minus 3, which is 4. So this is going to be the denominator. Now let's deal with the top. So we have this, which is the square root of 35 minus the square root of 15. And this is the final answer. Thanks for watching, guys. I'll see you soon.